NHPC Limited has proposed the 720 megawatts Mangdechhu Hydroelectric Project on the Mangdechhu River in Bhutan as a run-of-the-river scheme. As the project is located in the Himalayan region, heavy sediment inflow is expected to fill the reservoir live storage quickly. To restore live storage capacity, annual drawdown flushing through low-level sluice spillways has been planned. CWPRS was assigned to carry out hydraulic model studies to determine suitable flushing discharge and flushing duration. The project consists of a concrete gravity dam near Chunjapang village. The dam is about 56 meters above the riverbed. The annual sediment load of catchment is about 3.34 lakh tons. The reservoir is about 800 meters long, with a gross storage of 2.128 million meter cube and live storage of 1.171 million meter cube between FRL EL 1747.00 meter and MDDL EL 1730.50 meter. 4 gated spillway bays are provided to pass design floods. The power intake is located near the low-level spillway on the left abutment. Initially, the power intake was planned at location A near the extreme left pier. Subsequently, it was found that the bearing capacity of the rock at this location was not sufficient. Therefore, two alternative intake locations at B and C were suggested by project officials. To select the best option, all 3 intake positions were studied on 3D physical model. The final intake alignment was to be adopted based on the results of the following studies, such that there is no deposition left near the intake area. Accordingly, the model of Mangdechhu Reservoir was constructed to a geometrically similar scale of 1:100 for the reach of Mangdechhu River from 825 meter upstream to 200 meter downstream of dam axis. The dam, spillway and intake structures were reproduced accurately. The expected siltation profile after about 11 years, provided by NHPC, was reproduced in the model. Flushing discharges of 100, 150, 200, 250 and 300 meter cube per second were tested. Initially, flushing studies were carried out for different discharges and durations with intake alignments at AA. For intake AA, effective sediment removal was observed. For lower discharges, 100 to 150 meter cube per second, it was observed that there was only marginal increase in flushing efficiency beyond 12 hours. For higher discharges, 200 to 300 meter cube per second, most of the sediment was getting flushed within about 6 hours, and area near the intake remained clear. With this A alignment, it was observed that area near intake was remaining free from sediment deposition. Similarly, the studies were carried out for intake locations at BB and CC. For intake BB, there was marginal reduction in the quantity of sediment flushed for all the discharges. Intake CC, shifted slightly for better foundation conditions, showed performance similar to AA, especially for higher discharges. The studies conclude that reservoir flushing is effective for sediment management at Mangdechhu Hydroelectric Project. For low discharges, flushing duration need not exceed 12 hours, while for higher discharges, about 6 hours of flushing is sufficient. Intake alignment strongly affects sediment removal. Intake AA is the most suitable from a sediment management point of view. Intake CC is acceptable considering site conditions, and recessed intake BB is not recommended due to persistent sediment deposition.